Assalamu alaikum. This is an extra class for SI based quantities. The main purpose of the class is to do some practice questions on very basic nature. This is for base quantities, chapter 1, only the base quantities. I'm starting with the question number 17. You can look at the year number always. I'm starting with the first question, that is question number 17 on this screen. You can answer me on chat. You can answer me on the Zoom chat. And physical quantities can be classed as vector and as a scalar. Vectors are those quantities which are always with direction by nature, and scalars are those quantities which are by nature without direction. Which pair of quantities are both vectors? Kinetic energy and elastic force. Force is a vector, energy is a scalar. Momentum is a vector, time is a scalar. Velocity is a vector, electric field strength is a vector, weight is a vector, and temperature is a scalar. So please respond on the chat that what answer do you think should be there? Right, C is the vector. Majority people gave the right answer. Three of these quantities have the same unit. Which quantity has a different unit? Such questions can be either solved by base unit. Such questions can either be solved by base unit or derived unit or by formulas. So either you translate them into base unit and you can compare. Like power into time. Watt second. What is power itself? Joule per second. Joule per second into second will be equal to joule. Second will be cancelled out. Force is Newton. Newton is equal to kg ms minus 2. Rate of change of momentum. You haven't done this with me, but I have to, I can tell you the formula. And it is impulse, which is rate of change of momentum. And in physics, when something is divided by time, it is called rate. So mass is kg, velocity is ms minus 1 upon second. So if you bring this second up, now translate joule into further Newton meter kg ms minus 2 into meter kg m square s minus 2. Energy upon distance, joule upon meter. So it will be joule per meter. Joule will be Newton meter into per meter. Meter cancel. Newton left over. And Newton means kg ms minus 2. Now, examiner says which quantity has a different unit. I have worked out here and I want everyone to do the same. A-level questions, MCQs are proper working jobs. You can't guess it directly. So I have worked out every unit. So you have to look at the answer. So majority people gave the right answer C. Which pair of quantities contains one vector and one scalar? Displacement vector, force is a vector, energy is a scalar, power is a scalar. Acceleration vector, momentum vector, velocity vector, and distance scalar. Question number 19. Now give the answer for 19. Actually, it would be ideal that if you are answering a bit early, so write the question number also. One vector and one scalar. One vector and one scalar, question number 19. Okay, majority people are saying D. Okay, good. Sami, you are already in the class. Then why you need any password ID? Uh, please WhatsApp me. What you want? Please WhatsApp me because I know, but the same. If you open the WhatsApp on your laptop, you can connect from the same. But anyways, you send me up a WhatsApp. I check if I can share with you the. Please keep all of you camera off. Question number 20. Which pair includes a vector and a scalar? Displacement vector, acceleration vector, force vector, kinetic energy scalar, power scalar, speed scalar, work scalar, potential energy scalar. He wants to have a vector and a scalar. One property Q of a material is used to describe the behavior of sound waves in the material. Q is defined as the pressure of the sound wave divided by the speed v of the wave and surface area of the material through which the wave travels. This is the same category where examiner actually is trying to trap you in a new formula. What are the SI base units of Q? Remember, P is pressure. Pressure is Pascal. So I start my working. I write Pascal here. Velocity is ms minus 1. And what is capital A? Area. is meter square. You have to, everyone has to work with me and work down the steps. Newton per meter square. In the denominator, there is a meter and a meter square. So it will be meter cube S minus 1. If I take this meter up, it will be minus also. So Nm minus 2, I'm taking them up now. Meter minus 3 and S will be plus 1. It will be Newton M minus 5 S1. Break Newton also, kg ms minus 2 into m minus 2 into m minus 3 and S1. Now, if you see, I have a meter 1. I made this step to make it clear again. I have a meter 1 and meter minus 5. So if you have worked with me, you will understand it. If you are just looking at the working, then it will not be an improvement. Minus 2 on second plus 1 will be minus 1. So S minus 1. So look at the working and tell me with question number 22. 22 answer. Majority people are saying C. Good. If you have properly worked with me, you can always look at the working. We are now on question number 23. The unit of resistivity expressed in terms of base unit is given by this. This is the formula for resistance. Look at the formula for resistivity. I have worked the first two steps. Now, the unit of resistance is omega. How I can find the unit of omega? Let me work separately for omega. If you remember it, resistance is equal to voltage upon current. So R, if I take the units here, I do not know the resistance of omega. So R is equal to omega volt volt upon ampere. I stop again here so everyone can catch up with me. I actually do not know what is omega. So I'm working for omega. I'm getting omega as volt upon ampere. What is volt? O-level physics formula, V is equal to W upon Q, which is volt. Volt is equal to joule per coulomb. Look at this working. So I bring joule per coulomb here. Upon area is meter square. Now, what should I put for joule? Joule is Newton meter. What should I put for coulomb? For coulomb, it is ampere into second with power -1 upon meter square. One meter will cancel. Newton, ampere -1, second -1. Newton is kg, ms -2 into ampere -1, s -1 upon meter. No, in the formula, in the unit formula, there is a confusion. I want to clear it because there is a minor confusion occurring. Look, then when you write the formula, look, this one is area. And when you write here, this is not area, this is ampere. In the unit side, the letter A means area. Oh, sorry, ampere. In the formula side, letter A means area. It's a formula for resistivity. Now, help me to simplify this whole thing. I can still cancel another meter. Kg, S -2 and S -1. So it will be S -3 and A -1. Put it here in omega. I have found separately the value of omega. So I'm putting it here. My omega is kg s minus 3 into a minus 1 into meter. So when I simplify it, I can write it kg s minus 3 a minus 1 into meter. There is some mismatching now. I think we have a mismatching coming. We have to check our answers again, working again, sorry, because kg is matching. S is matching with z minus 3. I have made a mistake somewhere. Let me show you the mistake. This is the mistake. I have wrote it right, but later I made it by mistake. And this is something some people were already pointing out, that this letter is A, ampere, and it should be ampere here. So I got a mistake here and I'm now correcting it. So please correct with me. The denominator is not A for area, it is yes, I got the mistake. Thank you. So this was the mistake, and let's do from this point again. I'm rectifying this position because it was ampere. So if I write joule into meter and the denominator is ampere, it will remain Newton meter A minus 1 S minus 1 upon A. Now the denominator goes up, Newton meter A minus 2 S minus 1. So this is the correction. Now you have to move it for omega. Or if you want, you can further simplify it here and then you can move. It's your choice. You can simplify. That is because Coulomb is minus 1. Na? Some people are asked me, it will be extra time wasting because it's a small error. So no need to do it the whole. People can try to do the whole from the start. Newton meter can be further broken down into kg ms minus 2. AS minus 1 is coulomb. Remember that some people are asking for coulomb. Coulomb actually is the unit of charge. Coulomb is ampere into second. Just memorize it. Coulomb is ampere into second. So Newton is kg ms minus 2 into meter ampere square s minus 1. Kg m square. There is a square and there is a power minus 1. So if you combine it, it will be m square, a square, and s minus 3. Now put the value here. If you bring the value here now, omega is kg m square a minus 2 s minus 3 into meter. Kg m cube a square s minus 3. So now you can match it with the question equation and you can find, you can now compare it with the question kg with kg, m cube with x cube, a minus 2 with y minus 2, s minus 3 is z minus 3. It doesn't matter whatever you formula you use, you have to, in any way, you have to find omega. And whatever formula V is equal to IR, R power, and etc. Many formulas are there, but resistivity has one formula. Now, majority people are saying B is the answer. Look at question number 24. What is the unit of power expressed in SI base unit? Power main formula is work upon time, which means joule per second. You can write it JS minus 1. Joule can be written Newton into meter into S minus 1. Work out with me. kg, there are two m's, m square, s minus 3. So majority people are finding it. The answer is A. (27). A wave has a frequency 5 gigahertz. Unit conversion is there. Unit conversion is their favorite topic and they really play around it. So number 27, a wave has a frequency of 5 gigahertz. What is the unit? Sorry, what is the period of the wave? So first we write frequency. How much power should I give for giga? The power for giga is 9. What is the formula for time period? Time period is equal to 1 upon frequency, 1 upon 5 into 10 to the power 9. Can anyone solve this? How much is 1 upon 5 into 10 power 9? Or we can leave it here because it's a second. We can leave it here in this version because it is second. Now it is in second. If I convert it into microsecond, fine, thank you. Achha, now we have to convert it. It's a microsecond, nanosecond, then again nanosecond, then picosecond. I have it now in second. I want to convert it, suppose, in nano. Nano means in the lower side, in the diminishing power, it's 10 power 9 for division purpose. Please convert it into nanosecond. Let's check first B. The answer written here is nanosecond. How I can convert second into nanosecond? I have shown nanosecond conversion. Now try microsecond. Can you solve this? Anyone can solve this? Where, sir? Where is the issue? Convert second into microsecond. You can but convert. You can convert it by, this is a calculator work, na? This is a calculator work. So similarly, try to convert it into pico. I have shown this working. It will take you to microsecond. Then 1/5 into 10 power 9. How much is pico? Right. So please convert it. I am waiting for these two results. I need people to solve for me these two question mark working. Okay, it's coming 200 here, which is matching. It's coming 200 here. Here it is coming 0.2 into 10 raised to power -3. So micro is also not matching. 200 picosecond is matching. So this answer is matching. Nanosecond is not matching. Microsecond, you people can test. If you convert it, you will get 0.2 into 10 raised to power -3. So micro is also not working. Okay, this confusion -12, I want to clear again. When you say 1 picosecond is equal to 10 power -12 second, that's right. But look here, I am going from second to picosecond. So when you want to go to second to picosecond, it will be 1 second is equal to 10 power 12 picosecond. Some people are having this confusion, so please make it clear. This is right, it is 10 power -12. That 10 power -12 is second. When you shift from second to picosecond, it will be reversed. So everyone should make it clear. So people should make some people are having this confusion. Then why I am converting it from +12. I'm converting it for +12 because I'm going from second to picosecond. Anyways, we can check the working. If some people told me 200, if there is a mistake, we can check it, but we should move forward. Check the calculation. If there is any confusion, you people can ask me later also. Some people are still having a confusion in this calculation. Let me check the calculation also. Yes, it's coming 200. 200 is coming fine. I have checked it also. Now, question number is 29. Which row shows an SI base quantity? There are 7 base quantities. There are 7 base quantities. Remember them. And now you can tell me which one of them. Charge is not a base unit. Charge is not a base unit. current can be, potential difference is a derived unit, temperature is there, but he's making a trick. Temperature is right, but temperature is should be in Kelvin. So even though it's right, but this is wrong. 29B. Then question number 30, I'm not doing 30 right now because estimation is not my concern. But I always tell my students that you have to be ready for strange questions. Like you can see the options here, that the kinetic energy of a bus traveling on an expressway, the power of a domestic light, the temperature of a hot oven. So normally we do not come across these all units in our country. People aware of domestic light power, that's right. But temperature of a oven, we normally do not look at that. We just put the thing and heat it up and just eat it. So these questions, these type of estimations come always very problematic. I'm focusing on SI base units right now. Which unit is equivalent to Coulomb? Remember, Coulomb is equal to ampere into second. Coulomb is ampere second. So first option is ampere per second. So that option fails. Joule per volt. Joule per volt. Okay, joule is Newton meter and volt. What is volt? Volt is joule per coulomb. Joule upon, what is volt? Joule per coulomb. You can cancel joule and coulomb will come up. Watt per ampere, W per ampere. What is watt? If I recall everyone, the famous formula P is equal to VI. So power is watt. Watt is equal to volt into ampere. So it is volt into ampere upon ampere. Ampere cancel. It comes down to volt. Watt per volt. So watt per volt. It is volt per ampere upon volt. You can cancel volt and you will get ampere. So now 32. Help me to locate 32. He wants me to get coulomb. He wants me to get coulomb. I have worked every answer here. Majority people are reading it correctly. The answer is B. But I hope the people should understand that you have to do this working as I am doing it. And I know without doing this, you can't actually get these questions. They are so close and so challenging. So everyone should understand a very important feature, that you have to do working for paper 1 like you used to do working for paper 2. So we keep it up to here, and we will inshallah continue in our next class. Allah Hafiz.